Hello guys, my name is Tita from Group A. In this part, we will learn about index or image analysis. Before we talk about index, let's start with remote sensing. What is remote sensing? Remote sensing is the process of detecting and monitoring the physical characteristic of an area by measuring its reflected and emitted radiation at a distance, typically from satellite or aircraft. Special camera collect remotely sensed image, which help researchers sense things about the Earth. What about satellite remote sensing? Satellite remote sensing, which is the monitoring, evolution, and prediction of the research and features of the Earth's surface and its atmosphere from satellite, is an exciting, fast-growing technique used by environmental scientists to improve their knowledge of our planet. Now, let's jump to index or image analysis. Did you ever heard about index before? In remote sensing application, the vegetation index is reflection the level of greenery of the vegetation, which can also be used as a condition parameter draw.
Image satellite is special to transmit data wirelessly, communicate via radio frequency. Image is a record image of an object, usually in the form of an image on a photograph produced by means of optic, electro-optic, optical mechanic, or electronic. Satellite images, namely images made from outer space. This image is further distinguished by its use, namely, for the first, satellite imagery for planetary sensing. Example, Viking satellite imagery from USA. Venera satellite imagery from Russia. Second, satellite imagery for weather sensing. Example, NOAA from USA. Meteor image from Russia. Third, satellite imagery for sensing Earth resources. Example, Landsat imagery from USA. Soyuz image from Russia and Spot image from France. For the last, satellite imagery for ocean sensing. Example, CSAT image from USA. The benefit of satellite imagery are utilization of accurate imagery in making regional maps, and utilization of satellite imagery for infrastructure.
Spectral resolution. Spectral resolution describes the ability of a sensor to define fine wavelength interval. The finer the spectral resolution, the narrower the wavelength range for a particular channel or band. Spectral resolution can be further defined as how many measuring points are within the spectral result. If one uses a fixed array detector, then how many array element pixels are there in the measured spectrum? Assuming a 400 nanometer range, 380 nanometer to 780 nanometer. One might have, for example, 256 or 128 pixels, resulting in either 1.56 nanometer per pixel or 3.125 nanometer per pixel. Then, multispectral imagery. Multispectral imaging is the extension of white light imaging to incorporate better spectral resolution, resulting in improved ability to distinguish different chromosphere in the tissue. As with other applications of multi or hyperspectral imaging or MSI, such as remote sensing or production line inspection. The use of this technology requires a compromise to be struck between the spatial, spectral and temporal resolution with the ideal interventional equation consisting of a detailed spectral signature for each pixel in the image at video rate. Thank you.
Perkenalkan, nama saya Fikri Fauzul Hamdi dengan NIM 20135111007. Di sini saya akan menjelaskan tentang what is spectral indices and the story of it. Jadi, spectral indices are combinations of spectral reflectance from two or more wavelengths that indicate the relative abundance of features of interest. Vegetation indices are the most popular type, but other indices are available for Barnett areas, man-made, built-up features, water, and geologic features.
First form of spectral indices. Normally different vegetation index or NDVI. The NDVI index is a simple graphical indicator that can be used to analyze remote distance measurement with the observed target containing live green vegetation or not. Enhanced Vegetation Index EVI. EVI is an optimized vegetation index designed to exchange vegetation signal with enhanced sensitivity in high biomass areas. Soil Edges Vegetation Index or SAVI. SAVI empirically different NDVI products have been shown to be unstable, varying with soil color, soil moisture, and saturation effect of high density vegetation. Last, Modified Soil Edges Vegetation Index or MSAVI. MSAVI is a vegetation index based on the modified L correction factor of SAVI. Both vegetation index indicates this purpose is to improve the brightness level of the soil color from the cover different vegetation.
Yang berikutnya adalah development of spectral indices atau indeks perkembangan spektral. Perkembangan indeks spektral berfungsi untuk mendapatkan informasi baru dari data spektral. Perkembangan indeks spektral bisa terbagi dengan dua cara, yaitu yang pertama adalah transformasi yang dapat mempertajam informasi tertentu, namun sekaligus menghilangkan atau menekan informasi lain. Jadi transformasinya dilakukan dengan cara menonjolkan beberapa informasi saja, sedangkan informasi lain ditekan atau dikurangi atau dihilangkan. Yang kedua adalah transformasi yang meringkas informasi dengan cara mengurangi dimensionalitas data. Salah satu metode yang menggunakan transformasi yang mempertajam informasi tertentu namun mengurangi informasi lain adalah NDVI atau Normalized Difference Vegetation Index. Nah, Normalized NDVI ini digunakan untuk menonjolkan penampakan vegetasi dengan sangat jelas dibandingkan objek yang lainnya. NDVI ini menonjolkan kerapatan vegetasi namun mengurangi refleksi dari lahan terbuka dan lahan yang sudah dibangun. Transformasi NDVI menghasilkan citra yang memiliki informasi vegetasi dengan visualisasi berdasarkan nilai rona. Nilai rona memiliki interval nilai min 1 hingga 1. Nilai tersebut akan menggambarkan objek perairan, objek lahan terbuka, dan penutupan lahan vegetasi. Nah, NDV ini menggunakan rumus band NIR. Band NIR ini adalah band inframerah dekat di satelit Landsat yang memiliki tingkat sensitivitas yang tinggi untuk mendeteksi vegetasi, sedangkan refleksi untuk identifikasi lahan terbuka dan lahan terbangun sangat rendah. Jadi band NIR ini memiliki sensitivitas refleksi terhadap vegetasi yang tinggi. Nah, band NIR ini dikurang dengan band visible, dibagi dengan band NIR ditambah band visible. Band visible adalah saluran nampak. Baik, segitu saja dari development of spectral indices. Bisa dilanjutkan dengan teman saya.
First thing first, let me introduce myself lah. So my name is Riandra Cira Pratama. So and then my student ID number is 191 35 11 070. So here I'm going to continue to discuss about spectral indices. So as my friend talked to you before, you already know what is spectral indices in general, the introduction of it, and then the characteristic of spectral indices itself. Even example of the spectral indices like NDVI for water extraction, and then NDVI for vegetation. Even development of the spectral indices like AWA, automatic water extraction index, and then many more. So in this time I will going to discuss more deeper. I'm trying to answer a question like what spectral indices usage in research. Yeah. So I collect three research article to this some kind like study cases. So I will try to give you a big picture of how spectral indices used in research in general. So the first article is spatiotemporal variations in the accurate surface water temperature from 2001 to 2017 under the influence of climate warming. Yeah, so actually, as a project background, they want to know the lake surface water temperature, or LSWT, using Modis-Terra, 1 kilometer. Yeah, so Modis-Terra satellite imagery is actually have 1 kilometer spatial resolution. So when they actually using index, so the spectral index actually help them to create a boundary for boundary of the lake itself lah. So the term is boundary extraction lah, because it's so hard to interpret in Modis-Terra, which is have in a pixel. The pixel is 1 kilometer, and the lake itself is not too big yet. So they're using another imagery which has 30 meter spatial resolution. Landsat 5 and Landsat 8 imagery, and then to extract the boundary itself, they're using the NDVI, normalized diffraction index, because they want to extract the area of the lake itself. And then after they are extracting the lake itself, and they subset the Modis-Terra imagery using their boundary lah. And another article is talking about mangrove. This time is talking about mangrove. So the title is the Google Earth Engine Mangrove Mapping Methodology, or GMMM. So they are actually experimenting how to use Google Earth Engine for mapping mangrove lah. They use very many spectral in this. I give you a list. Wait a minute. So yeah, if you want to mangrove mapping, do research about mangrove mapping, this will be quite generous reference to start from, because they are actually have a list for spectral index they use. Let's say simple ratio, and then normal different vegetation index, normal difference water index, and then the modified one, and then combined mangrove recognition index, and plenty more. Optimized soil adjusted vegetation index. So the combination of the spectral index will create a generous amount of border between mangrove and another vegetation, and another land cover lah. And then my latest project is actually using spectral index to do shoreline extraction. So I'm using NDVI, and then AWE, automated water extraction index, to separate water body and the mainland itself. So this is the equation of the NDVI, and then the NDVI, and then AWE itself. So there's actually very many index out there, but I think this discussion will give you a big picture lah, at least a big small picture lah, about how do you use spectral index in your research. To close thing up, to wrap thing up, I will say thank you for watching, and I hope my video is help you guys, and see you next time. Thank you.